All right, Calculus 30. This is number 5 in section 3.5. Related rates. Related rates. So a stone is dropped into a lake, creating a circular ripple that travels outward at a speed of 25 centimeters per second. So a stone in a lake, a ripple. Okay, so the ripples emanate from where the stone is dropped in a circular pattern. So we're dealing with a circle. This is an overhead view of the rock that dropped in the lake and the wave, right? So the circular ripple is traveling outward, right? Can you see that? It's traveling outward from where the rock was dropped. So if the wave is traveling outward at a speed of 25 centimeters per second, okay? So look at, this is a length, right? Centimeters. So if you're saying, well, that the area could be expanding, maybe it's talking about the area there. Well, the units for area expanding would be centimeters squared, so it's not area. What we're talking about here is the rate of change of the radius. So the rock drops and you have this circle and it's going out like this, and so from where the rock dropped, the circle is going out at 25 centimeters per second. 25 centimeters per second. That's the rate of change of the radius. So r prime is 25. And we'll just leave the units up there in the question and come back to them later. Okay, so stone drop, circular. Okay, so, find what are we finding? The rate at which the area within the circle is increasing. So area prime, A prime, is what I'm trying to find out. Awesome. Well, this is a related rates question, so we should be given a rate, and we should have to find a rate. And then we're always going to be told at what point in this situation are we supposed to be calculating this rate of change, because this rate of change will probably be changing throughout the situation. Right? As time goes on, that rate will probably vary. So we have to take a snapshot in time when we're going to find this rate. So at 4 seconds. Now what is that? 4 seconds is what? That's like time, 4 seconds. So, okay, so is that going to give us an A? Is that going to give us an R or something else? So what is 4 seconds going to do for us? We'll come back to that, okay? Let's come back to that. So the next step in these questions are, what is the equation / formula, whatever, that relates A and R, area and radius? Well, for a circle, that's a slam dunk. The area of a circle is pi r squared, right? So that's the formula that relates area and radius of a circle, the area formula. So now that I have that, I'm going to differentiate with respect to time. Very important. So I'm going to implicitly differentiate with respect to time. So that means that A, the derivative of A is A prime. The derivative of pi r squared, well, pi is just a number, so I'm going to use the power rule. 2 pi r to the power of 1 times r prime. Because again, I'm not differentiating with respect to r or respect to a. I'm differentiating with respect to time. So the derivative of r is r prime. The derivative of a is a prime. Okay, awesome. So now let's take a look here. I'm trying to find a prime. Good, that's taken care of. R prime I'm given. Awesome. I need r. I need r at 4 seconds. R at 4 seconds, okay? So this is where you use your logic thinking, and you know that, hey, this is a circle. So at 0 seconds we have 0 radius. At 1 second, what do I know? What's 25? The radius is 25 at 1 second, right on. What's the radius at 2 seconds? 50. 3 seconds? And finally, 4 seconds, the radius is? Right on. 4 seconds that means r is equal to 100 centimeters. So 4 seconds means at r equals 100. Is that okay? That makes sense? So take what you're given and try and use find what you need. So in this case, we could use that time to find r. So if the radius changes at 25 centimeters per second, after 4 seconds, it's 100 centimeters out. So a prime equals 2 times pi times r is 100 at this point in time, and r prime is 25. Okay. So I can now just multiply everything, and I get a prime equals 5,000 pi. That sound about right? 200 times 25, 50 times 100, 5,000 pi. And that's going to be what? Area changing. So area, what's the units of length is centimeters. So centimeters squared per, what's the unit of time I'm dealing with? Well, seconds here. So it's going to be centimeters squared per second. And as a decimal, you could just do that on your calculator and get a decimal, right? No problem. So 5,000 pi is about 15,707. Okay. So we'll double check that. Is that the correct answer? Yeah? Looks good? That's what you got? Or is that what the back of the book has, or whatever? Okay. All right, any questions about that? Good? Good? All right. All right, good job.